Hi, hope all of you are doing fantastic. Preparation must be going good. 2 more months, and you know the day is going to come. All the best for the preparation. All the best, all of you. All right. So let's get started with respect to the video solutions series. This one is of geometry. Geometry with respect to this Ssc Cgl exam is, man, very important. Good number of questions appear from this particular topic, both in tier 1 as well as tier 2. So what's the difficulty level then? Man, difficulty level is actually very simple, very easy. What kind of books should we refer, especially for geometry? I have seen in YouTube many students ask for geometry videos and the resources. You already have it. You know where? It's in your 8th standard, 9th standard, 10th standard textbooks. None of the books, aptitude books, can actually match what you have already learned. It's going to be just a revision for you. Whatever you have learned in 3 years, okay, 8th, 9th and 10th, whatever you have learned, you can actually revise now at this age in 2 or 3 days. And I'm talking about normal human beings, okay? Then we were kids, high school kids, it definitely would be difficult for us to digest all that. But now, I mean, the maturity and the understanding level, the intellect, everything is entirely different. So when you go back to those books and start reading, you will finish all those 3 books. I'm talking about only geometry, all right? Only geometry part in 2 to 3 days. If you can do that, you don't need any aptitude book to actually solve the questions in Ssc Cgl. Okay, let's get started. So my suggestion is go through those 3 books. You will be very confident and then attempt directly the questions of this particular mock test. Later come and watch the video. Hope you have taken the mock test. I'll start with the solutions. Well, I will be using the same software website that I have used for explaining heights and distances in trigonometry, that is geogebra.org. Great. So let's get started with the first one. In a triangle, if 3 altitudes are equal, then the triangle is. Okay. So what I've done here, just randomly taken, I have drawn a triangle. I haven't kept A equals B equals C or anything, just a random triangle. All right. Now what they are saying, let's understand that. A line perpendicular to one of the sides and joining the opposite vertex becomes the altitude. Okay. Now what they are saying, the altitude is same, is what they are saying. So altitude of a triangle is same, I mean all the 3 altitudes, only when the sides of the triangle are same. You can observe it here. Fine. In this case, it is not an equilateral triangle, so the altitude also will not be same. So when you make it an equilateral triangle, definitely the altitude will be same. It's a very fundamental concept. The answer is equilateral triangle. You can even visualize that. Only when there is symmetry with respect to sides, the altitudes will also be equal, right? For example, if it is an isosceles triangle, right, wherein 2 sides are same and the third one is different, the altitude of overall out of 3 altitudes, 2 of them will be of equal length. The third one will not be. Okay, so that's the role of the symmetry. You can visualize it. Great. Let's go to the next one now. Okay. If triangle ABC is an equilateral triangle, okay, fine. If ABC is an equilateral triangle and D is a point on BC such that AD is perpendicular to BC. Very simple, straightforward question. Let's say this is one side, another side. Great. This is A, B and C. Equilateral means all the 3 sides are same or angles are same. D is a point on BC. Let's say D is a point on BC such that AD is perpendicular. Now AD is perpendicular to BC. Now see, if this is perpendicular to BC, then obviously these 2 will be same in an equilateral triangle. Hope this is clear. Then the ratio of AB is to BD. AB is to BD. AB is to BD. Fine. which will be nothing but if this is 2, the length of the sides, if it is 2, then BD will be 1 and DC will be 1. So the ratio is 2:1. Great. Very simple question. Next one. Next one, question number 3. If the incenter of an equilateral triangle lies inside the triangle and its radius is 3 centimeter, then the side of the equilateral triangle is. Let's assume this is the incenter and the radius is LJ. Now we know that this angle is 90 degree, right? And since they've given equilateral triangle, if I join this, it becomes a triangle that is CLJ. And what will be this? 30 degree. Okay. So now you can go for the ratio. If this is 30 degree, the ratio between LJ and CJ will be 1 by root 3. Why? Tan 30, which is equal to, we know LJ, that is in radius is 3, divided by, let's say x. This is x. Okay. So what is x now? X is equal to 3 root 3. What have they asked? The side of the equilateral triangle. So if this is x, what will be JB? JB will also be 3 root 3. Yes, the reason is this particular point is it's perpendicular from the center and it is a perpendicular bisector as well of the side. So for that reason, it divides this particular side into 2 equal parts, which is equal to 3 root 3. So overall, CB or the length of the triangle will be 2x, which is 6 root 3. Answer is option. Clear? Next one. Alright, question number 4. They've given that ABC is an equilateral triangle. That means the angle is 60 degree, 60, 60. CD is an internal bisector of angle C. CD, this is an internal bisector of angle C. Alright. And then if DC is produced to E, that means in this direction, if DC is produced to E somewhere on this line in such a way that AC is equal to C and E, I mean CE. So I have to select one point. Let me select the point approximately, let's say here, wherein this length CE should be equal to AC. Okay. Then the angle CAE is equal to. So let me join these 2 points. Okay. So what is the angle CAE? What is this angle? Is the question mark. Fine. Now observe carefully. What is this angle? Can I say this is 30 degree? C is equal to 60 degree, 60 degree because it's an equilateral triangle, and CD is a angular bisector, so this becomes 30 degree. If this is 30 degree, this angle will be definitely equal to 150 degree because it's a straight line, or you can also take it with respect to the exterior angle concept. I mean, no, let's not make it complicated. It's very simple. It's a straight line and this part is 30 degree and the other one is 150 degree. Fine. So now the remaining 2 angles must be same. The reason is the sides, that is this one as well as this, they are same. Okay. So I will take this as beta. So 150 plus 2 times beta is equal to 180 degree, or beta is equal to 15 degrees. Hope this is clear. Answer is option D. Okay. No split screen now, full screen, because they have given the diagram. So if in a triangle ABC as drawn in the figure, let me just zoom it. Angle AB, length AB is equal to AC, AB is equal to AC, and angle ACD is equal to 120 degree. Then angle A is equal to, fine. So they are asking us what is this angle, and they have given AB is equal to AC. Alright, fine. It's a very simple question actually. If this is 120 degree, obviously this is 60 degree, which is given in the diagram. So if this is 60 degree and 2 sides are same, then the opposite angle of the sides must also be same. For example, if this is 60 degree, then this must also be 60 degree. If these 2 are 60, then what about this? This has to be 60 because the sum of all the angles is equal to 180 degree. So the answer is simply option B. Hope this is clear. Yes. Next one. Okay. a knowledge based question. The ratio of in radius and x radius in an equilateral triangle. So first of all, what is x radius? What is in radius? To know what is x radius, you should know what is x circle. This is x circle, all right. Assume that is an equilateral triangle. For any given triangle, be it equilateral or any other triangle, there will be 3 x circles, okay. One, the circumference joining this particular side. Similarly, the remaining 2 sides, there will be 2 more x circles. Fine. The radius of that is nothing but x radius, all right. So how do you get an x circle? If you project the sides further of, let's say, of 2 sides of an equilateral triangle, for example BD and CE, the projections, and then there is one more side, that is BC of the triangle. The circle should join, the circumference should pass through these sides, the points on these sides, okay. Then you get an x circle. In circle, I'm sure all of you know it. So in radius is to x radius, the ratio is 1:2, all right. The ratio is 1:2. And how is that? In radius is, if you take side as s of an equilateral triangle, it is s by 2√3, and x radius is s by √3. Please remember this. You don't have to go for the proof. If you are interested, please go for it, no problems, but not necessary for Ssc Cgl. But of course, it definitely builds curiosity, and you will learn more, no doubts about it. So now the ratio of in radius to x radius is s by 2√3 is to s by √3. You can see clearly that it is 1/2:1 or 1:2. Okay, the ratio is 1:2. Next one. Right, next question. The ratio of circumradius and radius of an equilateral triangle. So you can see, I've taken this from math.stackexchange.com. So circle is the one, the bigger one, right? And the in circle is this one. Now what they're asking is circumradius and radius of an equilateral triangle. What's the ratio between them? So again, knowledge based question. We can prove this, but just time consuming. So circumradius is nothing but AG, okay. Now AG is equal to A divided by √3, wherein A is nothing but the length of the triangle. So remember this. I'll ask you a question after this, okay. Listen to me very carefully. So AG is this, then I'll go with the in radius, basically the radius of this particular circle, in circle. Let me call this as GE, fine. So GE, that is in radius, this is circumradius, this is in radius, or basically they have just termed it as radius, fine, is equal to how much? A by 2√3. All right. So if this is the case, the ratio of circumradius to the in radius, obviously it is 2:1. This is double that of this. Now in an equilateral triangle, all right, we're talking only about equilateral triangle. What's the ratio of circumradius to x radius in an equilateral triangle? So you must be able to answer this question. So post your solution or the answer in the comment section, okay. If you have understood the previous question and this question clearly, you must be able to answer this question. Great. Let's go to the next one now. Question number 8. So if one angle of a triangle is equal to half the sum of the other 2 equal angles. Very easy, straightforward question. So let's assume ABC as 3 angles. Then what they are saying is A is equal to half of the sum of other 2 equal angles. That means B is equal to C. Fine. So let me call this as B only. Let me not call it as C. So half of 2B. So A is equal to B. That means even this is also equal. So A is equal to B is equal to C. That means the triangle that we are talking about is an equilateral triangle. Hope this is clear. Very straightforward, direct question. Let's go to the next one. Question number 9. The lengths of the sides of a triangle are ABC. If A square plus B square plus C square is equal to AB plus BC plus CA, then the following is. Look at the options. In the options, you can clearly see as equilateral triangle. So if this condition is not equal, that is a square plus b square plus c square, if it is not equal to ab plus bc plus ca, when a is equal to b is equal to c, only then we can rule out the option equilateral triangle. But if you assume a is equal to b is equal to c, then obviously it satisfies. Then the answer has to be equilateral triangle. Hope this is clear. You don't have to further go and try to solve. See, the moment you see symmetry in the equation, so even in the diagram there has to be some symmetry, right? Because the equation, any sort of equation which represents the diagram, it is a reflection of it. So automatically what can come to your mind is equilateral triangle. So if it has to be equilateral triangle, then A must be equal to B, must be equal to C. So then think about it. If A is equal to B is equal to C, left hand side becomes 3a square, right hand side also becomes 3a square. Then the answer is equilateral triangle. You don't have to actually solve for this question. Great. Next one. Okay, question number 10th. PQR is an equilateral triangle. PQR. MN is drawn parallel to QR such that M is on PQ and N is on PR. All right, M is on PQ and N is on PR, and it's a parallel line. Let's say this line. Okay. Fine. So where this is M and this is N. Great. Then if Pn is equal to 6, Pn is equal to 6, then the length of Mn is, observe very carefully, Pmn is similar to PQR, correct? Pmn triangle is similar to PQR, and how is that? You know, the angle is same, that is P, obviously it is same, and then two parallel lines. Okay, when there are two parallel lines crossing another line or intersecting another line, the angle what you have, they will be definitely same, right? So this will also be equal to 60 degree. This is also 60 degree because equilateral. So this is also an equilateral triangle. So if it's an equilateral triangle, what is Mn is also 6. Simple. Next one. Okay. ABC is an isosceles triangle such that AB is equal to AC, angle B is 35 degree, AD is the median to the base BC, find the angle. Okay, fine. So let's draw a rough diagram to understand what they're talking about. It's an isosceles triangle, so I will draw something like this, fine, wherein these two sides are equal, and I've clearly mentioned those sides as AB and AC. Angle B is given as 35 degree. AD is the median to the base BC. AD is the median to the base BC. Angle BAD. Angle BAD. This is the question mark. So if AD is the median, this is the midpoint on BC, and it's an isosceles triangle. That means this angle is also 35 degree. And look at the symmetry. The median is also the angular bisector of A in this case. So angle A, first of all, must be equal to 180 minus 35 plus 35, 70. 110 degree. If angle A is 110 degree, angle BAD must be equal to 110 divided by 2, because AD, which is the median, also acts as the angular bisector of A. The reason being, it's an isosceles triangle, and you can just observe it and solve it using the symmetry. This is 55 degree. Great. Let's move on to the next one. Okay, question number 12th. ABC is an isosceles triangle. Fine. ABC is an isosceles triangle with AB is equal to AC. Fantastic. A circle through B touching AC at midpoint. So this is midpoint. Let me call it as N. Intersects AB at P. So this is P. Hope this is clear. Hope the diagram is clear. Then AP is to AB. All right. What we need is AP divided by AB. Great. This is actually question from circle chapter more than triangle. What we use is the property of circle here. And what is that? what you see here, an is basically a tangent. The length of the tangent, that is an, if you square it, an square is equal to AP into AB. This is one of the properties of circle, very important property. Okay, where PB is a chord, and when you further extend the chord from this point P, it meets the tangent at A. Okay, in this particular scenario, what happens is the length of the tangent, when you square it, it will be equal to the extension, that is AP, multiplied by AB. Great. So we'll use this formula to solve this question. I'll show you how. I'll assume the length of this particular side, that is AC, which will be same as AB, as A. I'll assume AB is equal to AC as A. Then this is A by 2, that is AN is A by 2. Okay. Now I'll substitute that. AN square is A square by 4 is equal to AP into AB. AB is what? A. So what is that I want? I want AP by AB, which is same as AP by A. Why? AB is equal to A. Hope this is clear. Fine. So here you get A gets cancelled, and AP by A is equal to 1 by 4. A square and A gets cancelled, you get AP by A is equal to 1 by 4. Now, what is AP by A? AP by A is same as AP by AB, which is equal to 1 by 4. Answer is 1:4. Clear? Great. Next one. So the whole problem is dependent on one property of circle. Okay, if you know that, you can solve it, or else it's tough. Next one. Great. Look at this. Read the question. Read the question completely. Interesting, nice question actually. Simple one, but too much of data. They've given BAD as 15 degree. D is any point on this line. It can be any point. Okay, read the question completely and listen to the explanation. D is any point on this line wherein the perpendicular drawn on AB and AC. On AB, it becomes P. First of all, this point is D, right? This point is D, and P is on AB. Q is on AC. AP is A, AQ is B, angle BAD is 15, sine 75 is sine 75 degree. Can I say this is 75 degree? Yes, because it's 90 degree. P is perpendicular, PD is perpendicular to AB, BAD is 15 degree, so this angle D becomes 75 degree. Hope this is clear. What is sine 75? It should be expressed in the form of B and A. That's the most important thing, right? So sine 75 is equal to A divided by AD. What is AD? Can I write AD? Okay, before that, before we talk about AD, look at this triangle. So they have clearly mentioned it's an isosceles triangle. So if this is 15 degree of angle A, which is nothing but angle A is 45 degree, because it's isosceles right angle triangle. So this part will be 30 degrees. So if this is 30 degrees, can I say AD, or not AD, instead of AD, can I express B in the format of AD? In the sense, can I say AD cos 30 is equal to B? Just observe. AD cos 30 is equal to B. Yes. So what is cos 30? Root 3 by 2. Or AD is equal to B into 2 by root 3. Hope this is clear. Then substitute the value in this particular expression. You will get A divided by, what is AD? B into 2 root 3. So A root 3 by 2B. A root 3 by 2B is option C. Just you can watch this video once again. There is no confusion actually. Watch it clearly, you will definitely understand. Great. Let's move on to the next one. Next one, in a triangle ABC, AB is equal to AC. I'll just go with a approximate diagram. So AB, let's say this is AB is equal to AC. These two are same. Angle BAC, this angle is given as 40 degree. Then the external angle at B, okay. What is this angle? That's what they've asked. So how are you supposed to find this? Again, the same thing. When two sides are same, then two angles will be same. So I'll take this angle as alpha. This will also become alpha. So 40 plus 2 alpha is equal to how much? 180 degree. So 2 alpha is equal to 140, or alpha is equal to 70 degree. So if this is 70 degree, this value will be equal to 180 minus 70, which is equal to 110 degrees. Answer is option C. Great. Next one. Yes, 15th one, knowledge based question. I mean, you must be able to solve this. In triangle FGH, some triangle wherein three vertices are F, G and H is isosceles. Isosceles means two sides are same. Many questions has come from isosceles property. And FG is less than 3 centimeter. One of the sides, the measurement is less than 3 centimeters. GH is equal to 8 centimeter. Then the following, the true relation is, now isosceles refers to what? Two sides must be same. So FG is one side, GH is other side, and FH is other side. FH must be equal to either FG or GH, but we don't know what's the value of FG. Then what can we, how can we say anything about FH with respect to FG? Hope this is clear. So FH can be equal to GH alone to make this whole statement right. That is, only then it can become isosceles triangle, and FG can be anything, in the sense it has to follow the property of the triangles, that is there, but it can be any value less than 3, in the sense it can be 2.9, 2.8 or 2.5 or 2, whatever. Hope you're understanding it. So the right answer for this question is option A, GH is equal to FH. Now, why am I saying or being a little confused with respect to telling you that it cannot be any value less than 3? The reason why am I saying this is, I'm not calculating anything, but there is something that you need to understand. When you have a triangle, all right, let's say this is A, this is B, and this is C. Okay, the sum of any two must be always greater than C. Okay, or with respect to all the three, the sum of any two, for example, if A plus B, it has to be more than C, and not or, and B plus C must be greater than A, and A plus C must be greater than B. You take any two sides, the sum of those sides must be greater than the third side. So one of the sides is 8, the other one is also 8, then definitely anything above 1 centimeter, 0 centimeter actually, okay, can form a triangle, because at any point in time, if you see 8 plus this value, if it is, let's say, 0.1 also, all right, so 8 plus 0.1 is more than 8, or 8 plus 0.1, this 8 plus 0.1 is also more than 8. So if you take 8 centimeter and 8 centimeter, 8 plus 8, 16, that is more than 0.1. Okay, so this calculation I did not do while I was explaining. I hope this is clear. That's what I was a little hesitant with respect to telling you. FG cannot be anything less than 3, but since now we have calculated it very clearly, FG can be anything, any positive value less than 3. Great. Next one. Yes. Question number 16. ABC is an isosceles triangle. You can see it clearly. ABC, they have mentioned it's an isosceles triangle where AB is equal to AC. Okay, AB is equal to AC, which is circumscribed about a circle. If P is the point where the circle touches the side BC, if P is the point where circle touches the side BC, then which of the following is true? Look at the options. We are supposed to derive or establish a relationship between PC and BP. Okay, that is PC, this length, and BP, this length. Clear? Now, there is one property with respect to the tangents of circle. So what is that? From any point in time, from any point outside the circle, if you draw tangent, okay, the length of the tangents will be same. For example, from A you draw a tangent to a circle, that is Q. You can draw one more tangent from point A, that is AR, all right, or AR1. Fine. So the length of these two must be same. So what can we how can we use this property to solve this question? Observe carefully. If AQ, this is Q, all right, if AQ is equal to AR, then can I say BQ is equal to RC? BQ is equal to RC. BQ is equal to RC, I can say that for sure. Why? The reason is AQ is equal to AR, AQ is equal to AR, and what is AB minus AQ? AB minus AQ is BQ. Similarly, AC minus AR, AC minus AR is RC. So once I have found out that these two are same, okay, these two are same, the next thing is the same property. From point B, you can draw two tangents to the circle, that is BQ and BP. They must be same. All right. So if these two are same, similarly these two will be same, and then we can establish the relationship between BP and PC. That is BP is equal to PC. Hope this is clear. Okay. Great. So I mean, if you could not follow it, once again watch the video, solve it yourself, draw the diagram, and it's all surrounding, it's revolving around this property of circle, that is from an external point, if you draw two tangents to a circle, then the length of those tangents will be same. That's all. If you know this, obviously you can solve this question. Next one, let's go to the next question now. All right, question number 17. Simple, straightforward. You should be able to solve this question within 10 seconds. 5 seconds will go on reading, understanding, and the remaining 5 seconds in calculation. So what is that? ABC is an isosceles triangle. They're saying that AB is equal to AC, AB is equal to AC, and they've given that is equal to 15 centimeters. Fine. Altitude from A to BC, this is 12 centimeters. This is the altitude. So this angle is 90 degree. I need not explain that. The length of side BC is what we want. I mean, I'm explaining you, so I'm taking more than probably 20 seconds. But if you are doing it yourself, I mean, to understand this, how much time does it take? So what's the next part? The moment you see 12, 15, all right, and a right angle triangle, what has to come to your mind? If you have practiced enough, what has to come to your mind is Pythagorean triplets. Pythagorean triplets, in this particular cases, it is 9, 12, and 15. That is, 9 square is 81, 12 square is 144, and 15 square is 225. So 81 plus 144 is equal to 225. You have solved the problem. So if this is 9, this is also 9. Yes, the reason is this is an isosceles triangle, and this line is bisecting this particular angle because it is isosceles and it is perpendicular to the opposite side. Hope this is clear. Hence, this is going to be 9 and this is going to be 9. So 9 2s are 18 centimeters is the length of BC. Great. Next one. All right. Next one. In the figure given below, if AD is equal to DC is equal to BC. So let me zoom this. AD equals DC equals BC. All right. Yes. And BC is 96 degrees. That's given by already. Fantastic. This is sufficient for us to solve. Now AD is, I mean, even they have marked it. AD is equal to DC is equal to CB is what they have given, and they've also given the angle 96 degree. Okay. Then angle DBC, that is DBC, this is what we are supposed to find. Easy problem actually. Okay, let's see what we can do. First thing is, if this is 96 degree, all right, automatically what has to come to your mind? This particular angle, okay, the C, this angle must be equal to 180 degree minus 96 degree. That is first thing. All right. Next, these two sides are same, and also this and this, even they are same. That means this angle, I'll take it as x, and the one that we are supposed to find, even that I'll take it as x. They both will be same. Clear? And the other thing is, I will take this as y, this also as y. Hold on. So listen to me. We will definitely establish a relationship here. Yes. If then what will be this angle? This particular angle. What will be this angle? This angle will be 180 minus 2x. Okay, plus y is equal to 180 minus 96 is one relationship. Next, uh, 2y plus, what is this? This is 180 minus x. 180 minus x is equal to 180 degree. Yes, these two should be sufficient. 180 can cancel. You have 2x minus y as 96. Next, in this case, 180 gets cancelled. 2y is equal to x. Easy question. We want x. All right. So y can be substituted as y is equal to x by 2. So 2x minus x by 2 is equal to 96. All right. Or 5x by 2. 5x by 2 or 5x is equal to 96 into 2. Correct? 2 to the 4. Oh, sorry, not 5x, 3x. This is 4x minus 1. Right? So this becomes 3x. All right. So x is equal to 96 into 2 divided by 3, or it is 32 into 2. Right? 96 by 3 is how much? 32 into 2 will be equal to 64. Angle is 64, must be option C. Okay, now what we have done here, just understand, don't miss this out. It's a very nice question, very nice question. We haven't actually used this data, have we? Yes, we have, I guess. One second. Yes, we actually have not used that data. When we are adding 180 minus 2x, it is this angle and this angle. Yes, we have. Sorry, we have. Okay, great. So what have we done? The first thing is, let me just remove it off. Okay, what we have done is, first let me identify what is this angle. Okay, and express that, all right, in terms of these two angles. So I want actually CDB, so I will call it as x. If CDB is x, CBD is x, then CDB will also be x, because these two sides are of same length. Okay, then this angle will be equal to 180 minus 2x. Okay, what about this? I will call this as y, these two angles as y. All right, and I have to make use of this 96, that's an absolute value. Only then I can express these things or get the values of these from that 96. Okay, that is our absolute value, or what we know. Correct? So how can we utilize that? This is 180 minus 2x. This value plus y is equal to total length. The straight line angle is 180 degree minus 96 degree. If I remove this 96 degree, I will get y plus this angle, that is 180 minus 2x. This is the catch. So the moment you understand this, I mean, you have actually solved the problem. Okay, the next thing is very simple. X, and what is this angle now? This angle is 180 minus 2y. Correct? Why 180? The sum of three angles is 180 degree, right? So 180 minus 2y is equal to, it's not equal to 180 minus 2y plus x must be equal to 180 degree, because it's a straight line. We're talking about a straight line, and this angle is 180 degree. That's all. You have two variables, x and y, and you have two equations, you get your solution. So simplify this, you will get the answer. Okay, awesome. Let's go to the next one now. Right, question number 19th. Taking any three of the line segments out of segments of length 2, 3, 5 and 6 centimeter, the number of triangles that can be formed. It's a very basic question. Okay, but it's a very nice question, very important question. Many of the students, they actually skip this particular concept of triangles. I'll tell you what is that. Now before that, let's understand, they have given 2, 3, 5 and 6. Okay, 4 different line segments of, 4 different length. So now, how many different possible triangles can you actually make? Assuming that with all the 4, if you select any 3 randomly, okay, and you can actually make the triangle. If that is the case, then how many such triangles can you make? Let's just see that. I can select, let's say, 2, 3, 5 first initially. Next I'll select 2, 3, 6. Then I will leave 2, I'll go with 3, 5, 6. and then I will leave 3, I'll go with 5, 6, 2. Is there any other possibilities? There could be, it's a little confusing. So how can we remove our confusion? There is a way for that. We can identify how many such selections can be possible by, of course, our permutation combination knowledge. That is 4C3 is equal to 4C1. Basically, there are 4 objects, 1, 2, 3, 4. Out of these 4, you are selecting any 3. So that is represented as 4C3, which is equal to NCR equals N minus R. So 4C1, which is equal to 4. So there are 4 such possible. There is nothing other than this, other than these 4. Clear? Great. Now, how do we check this particular set, that is 2, 3, 5, can make a triangle? Now understand, very simple, very beautiful concept. In fact, if I have 2 sides, okay, let's say A and B, and this is C. The length of A and B, if you add them, A plus B, it must be greater than C. It must be greater than C. So visualize this, okay. For example, if this was a straight line, and this is A and this is B, okay. Now, if you bend this, right, if you bend this, only then you get a triangle. If you bend this, then there is a possibility for another line to actually join these 2 ends. If there is no angle at all, if both of them are on the same line, then how can you actually make a triangle? If both of them are on the same line, then A plus B will be equal to C. This is C. This becomes C. A and B will be equal to C. So for that to become triangle, these 2 sides have to either bend inside or on the other side. Correct? So when it bends, what happens to C? It has to reduce. Hope you are visualizing it. So when this has to reduce, it boils down to this particular equation, that is A plus B is greater than C. Right? Now that is valid not just for A and B, it has to be valid also for the remaining 2. I mean, if you take A plus B is greater than C, then B plus C must be greater than A, or we are left out with A plus C must be greater than B. This must be valid. All 3 must be valid. Okay, we have to check this validity with all the 4 options quickly. Fine, look at this. 2 plus 3 is not greater than 5, ruled out. 2 plus 3 is not greater than 6, ruled out. 3 plus 5 is greater than 6, 5 plus 6 is greater than 3, and then 3 plus 6 is greater than 5. Then this can make a triangle. 5, 6, 2. 2 plus 5, 7, which is greater than 6. 6 plus 2 is greater than 5, and then 5 plus 6 is also greater than 2. Definitely this will also make triangle. So you can make actually 2 triangles out of this. What was this? It's a very basic knowledge. It's a very basic concept, okay, in triangles. So you know this. There are a few questions which requires very basic knowledge and common sense and a little bit of calculation skills, right? Great. Let's go to the next one. Okay. Let me draw a rough diagram for read the question, everyone. There is a triangle, and the sides that are given in the ratio of 4x, 5x, and 6x. I mean the sides are 4x, 5x, and 6x because they are in the ratio of 4:5 to 6. In radius is given as 3 centimeter. In radius is given as 3 centimeters. Altitude of triangle corresponding to the largest side as base. Largest side as base is 6x. So this is your altitude. Let me call it as h. Well, if you have in radius, and then there is something also about h, what I will do is I'll equate the area of triangle, which I can get from 2 different ways. One, half into 6x into h, correct? Half into base into height. The other one is area of triangle can also be expressed in the format of in radius and semi-perimeter, that is in radius multiplied by s, semi-perimeter, which will be nothing but 3 into sum of these sides divided by 2, 15x by 2. That's it. Okay. So what I am trying to express is this is half into 6x into h is equal to 3 into 5x by 2. Hope this is clear. You can solve it now. X gets cancelled and 2 times, yeah, so h is equal to 2.5 is what you get, right? Sorry, this is 15, not 5, it's 15. 3 into 15, 15, right? 4x plus 5x plus 6x is 15. So you get not 2.5, instead it is 15 by 2 is 7.5 centimeters. That's it. Option A is your right answer. Alright, next one. The sum of three altitudes of a triangle is, look at the options, equal to the sum of three sides, less than, greater than, twice the sum of sides. It's an observation based question. Okay, if you can observe the diagram clearly, you can actually solve this question within seconds. Okay, what we are talking about is, let's say there's a triangle. Let's assume it's an equilateral triangle. All right, we can always assume, unless there is no constraints involved. All right, if it's an equilateral triangle, then a perpendicular, the altitude, okay, is, let's say, this line h. All right, now can I say that h is less than this particular side? Of course I can, because there's an angle, and let me call this as a, this side as a. A cos, let's say, this angle theta is h. You can clearly observe that a is always greater than h. All right, h is a projection of a in one direction, that is a cos theta is h. I hope you are following. Similarly, the other two heights or the altitudes will be less than the other two sides. So naturally, when you add all the sides together, the sum of it will be more than the sum of the altitudes, or the sum of the altitudes will be less than the sum of the sides. Hope this is clear. Look at the options. Less than sum of the sides, obviously that is the right answer. This question, I mean, if you get something like this, you should consider yourself as really lucky. If your fundamentals is strong, the moment you see the question, you can answer these kind of questions. Great. These are not knowledge based questions, these are not direct questions, but it's about the observation. You should understand the concept and observe things. So then this becomes like, within 5 seconds question. Next one. All right, next one, question number 22. This is not exactly a geometry based question. This I'm sure you would have solved this kind of problems in what's the name of it, directional sense, in logical reasoning. You must have solved something like this. Anyways, let's solve it. Now, to solve any problem in directions, I'm sure you know the fundamental, and that is, the fundamental is the directional sense. Directional sense is, this is north, this is south, and then this is what, east or west. West Bengal lies towards east. That's the mnemonic that I have. If you imagine India map on this, then West Bengal is somewhere here, right? West Bengal lies on the east of India, right? So this is west. So this is my reference. Okay, this is something which has to be there in your mind. Next, a man goes 24 meter due west. Somebody is, let's say this is the starting point, towards west means from here it is in this direction. Okay, in this direction, and they say it is 24 meters. And then 10 meter due north, 10 meter due north, let's say till here, north 10 meter. Then the distance of him from the starting point is, all right, this is what they are asking about, which is nothing but square root of 24 square plus 10 square. So how much will that be? Well, 24 square is 576. Remembering squares, it's really useful. And then 26 square is 676. Difference is 100. So 10 square gives you that 100. So 24 square plus 10 square is 26 square. Now, if you are, if you have practiced really well, especially geometry, then you will remember this in this, the subsection of Pythagorean triplets. So this is one of the Pythagorean triplets, 10, 24, and 26. Okay, the answer is option B, 26. Next one. All right, question number 23. Again, one more question with the concept of incenter. Question is, if I be the incenter of triangle ABC, angle B is 70 degree, angle C is 50 degree. Now observe. Let me draw a rough triangle without, any scale, just like that for our understanding. So let me call this as A, this is B, and this is C. Now what is incenter? We have already learned this previously. That is the line, the angle bisector of all three angles. Okay, so wherever it meets, this is in center, right? So they are asking us BIC. Before that, they've given B is equal to 70 degree. Now observe this. If B is 70 degree, what is this? 35, correct? Now if C is 50 degree, what is this? 25. Now what they've asked is BIC. Now BIC is nothing but 180 minus 35 plus 25, which will be equal to, this is 60, 180 minus 60 is 120 degree. Answer is option C. That's it. Great. Let's go to the next question now. Okay, question number 24th. In triangle ABC, angle A is less than angle B. Fine, angle A is less than angle B. Let's keep that in our mind. The altitude to the base divides vertex angle C into two parts. So altitude means, let's say if this is the altitude from C to the base AB, then this is 90 degree. Hope this is clear. And then they have given two parts is C1 and C2, with C2 adjacent to BC. Now this is C2, which is adjacent to BC, and this is C1. Then fine. So observe, there are two triangles here. Let me call this point as D. So in triangle ADC, angle A plus 90 degree, that is this angle D is 90 degree, plus C1 is equal to 180. Similarly, in triangle DBC, angle B plus 90 degree plus C2 must be equal to 180 degree. What does that mean? Both are same, these two entities. Then you can just equate them, and then you can cancel 90 and 90. You have C1 plus angle A is equal to C2 plus angle B. Then C1 minus C2 is equal to angle B minus C. Right? So look at the options. C1 minus C2 is equal to angle B minus C. You have that option. Hope this is clear. That's it. Let's move on to the next one. Okay, next question. ABC is a triangle and sides AB, BC, CA are produced to EFG respectively. Let's see what does that mean. Okay, I have a triangle here. Okay, A and then let's say B and then C. Fine. Now they are produced to, for example, let's say AB is produced to E, and then BC is produced to F. BC, which is BC, this is produced to, let's say somewhere here, F, and then CA is produced to G. All right, that's the meaning of it. There are 3 points. If angle CBE, that is CBE, this angle, all right, is equal to angle ACF, okay, to 130 degree. Great. This is equal to 130 degree. This is equal to 130 degree. Then the value of GA and B, that is this, is what we are supposed to find. Very easy question. Very easy question. What is this angle? This is 180 minus 130. Let me not write it there. I'll call it as alpha. Okay, alpha is equal to 180 minus 130. Why 180? 180 is because it's a straight line, and the other part of it, they've given clearly it's 130 degree. So this will be equal to 50 degree. So alpha is 50 degree. What about this? This is again the same thing, because this is 130 degree. So 180 minus 130 will be once again alpha, that is 50 degree. So now let me write this as 50 degree. This is also 50 degree. Okay. So if that is the case, what will be this side? This one. You can find out this. That is one way. Or the other thing is, what you can do, the sum of the other two interior angles is equal to the exterior angle. For example, let's say this is an exterior angle, right? This is the exterior angle, will be equal to the sum of these two. It has to be equal to the sum of these two. Why? Because this exterior angle plus angle A is equal to 180 degree because of the straight line concept. The second thing is, angle A plus the remaining two angles must also be equal to 180 degree. Hope you are following. So Naturally, instead of calculating this angle A, directly we can find out this particular value, that is nothing but 50 plus 50, which is equal to 100. Clear? Answer is option A. I hope you are following. I'm going a little faster just because we have to meet the deadlines. We have to release this project as soon as possible. So if in case you have any doubts, please feel free to ask any kind of doubts, be it here in the comment section or also in the assessment portal for this particular test, that is, let's say, geometry mock test. There will be a separate discussion forum for each question. We can have discussion there, but not necessary that you will have to take the mock test to have a discussion. You can post your comments in this particular video itself, and I will definitely clarify all of them. Great. Let's go to the next one now. Okay, let's move on to the next question. 26. Suppose ABC is a right angle triangle. All right, ABC is a right angle triangle where angle A is 90 degree, and then ABC, let's say AD is perpendicular to BC. AD is perpendicular to BC. Okay, this is D. AD is perpendicular to BC. Angle A is 90 degree. Great. If triangle ABC is equal to 40 centimeters square, triangle ABC, okay, triangle ABC is equal to 40 centimeters square, and triangle ACD, okay, triangle ACD is equal to how much? 10 centimeters square. The ratio of this. Now before that, before I take the ratio, can I say ADC, triangle ADC, or here itself, triangle ABC is similar to triangle ACD. Can I say that? Observe, in ABC A is 90 degree and in ADC D is 90 degree. Angle C is same because that is common, so that is sufficient for you to confirm that both are similar. Now if that is the case, this must be equal to the square, the ratio of the square of the bases. ABC, the base of ABC, here I will take it as BC, and then corresponding base of ADC, if you consider those two are similar, will be AC. It is AC square. Simple. So you get 40 by 10 to be equal to, what is BC square? BC square is, we don't know, we are supposed to find out that, okay, divided by AC square. AC is how much? The unit is 9, so it is going to be 81. So that gives me BC square to be equal to 81 into 40 by 10 is 4 or 2 square, or okay fine, let me write it as 4. So what is this? 9 square into 2 square, or that is BC square, or what is BC? BC is equal to 9 into 2, which is 18 centimeters. 18 centimeters is the right answer. Okay, question number 27 now. If the median drawn on the base of a triangle, okay, first let me draw a triangle. All right, now what is median? For example, if I draw a line from this particular vertex and divide the other side, the opposite side, equally, okay, that is the median, right? For example, if it is, let's say, ABC and BC length is x, okay, BC is x, and if AD is the median, then BD will be equal to x by 2. Similarly, this will also be equal to x by 2. That's what they are saying. Then another data what they have given is, if the median drawn on the base of a triangle, let's say this is the base, BC is the base and AD is the median, if AD is half its base, that means AD is also equal to x by 2. All right, now it becomes very simple, very easy. How? Observe the triangle ABD. There are two sides which are of same length. If there are two sides which are of same length, then the opposite angle of those sides will be equal. For example, x by 2 opposite is this and AD opposite is this B. I'll call it as alpha. If that is the case, the same thing will happen on the other side of the triangle. So I'll name this as beta. This will also be beta. Hope this is clear, because DC is also x by 2 and AB is anyways it's x by 2, right? So once we establish this, the next part is the sum of all the angles in the triangle ABC. That is the reference. The sum of all the angles must be equal to 180 degree. So 2 times alpha plus beta will be equal to 180 degree, or alpha plus beta is equal to 90 degree. So we have got alpha and beta, alpha plus beta, when you combine these two it becomes 90 degree. It means angle A is 90 degree. So if it is 90 degree, it's a right angle triangle, right? Option A. That's it. Great. Let's move on to the next one. Next one. To solve this question, you must be knowing or having a very minimal knowledge about the triangles and circumcircle. I'll show you what is that. Let's say this is a right angle triangle. All right. And I want to draw a circumcircle. Circle through 3 points. Yes. All right. Great. Show label, no, fine, great. Now this is 90 degree, B is 90 degree. If this is the case, on a right angle triangle, when you draw a circumcircle, then the hypotenuse becomes the diameter of the circle. All right, this is a very basic concept. The other thing how you can understand this is, if you draw a circle and then you have a diameter, all right, and if you draw two lines from the two ends of the diameter, it will always subtend the angle 90 degree on the circumference. For example, let's say that if you consider two chords which are passing through the opposite sides of the diameter, or in simple words, let's say you join these two diameter with two lines wherein the other end of the lines lie on the circumference. Okay, this angle will also always be 90 degree. Hope this is clear, right? Great. Now read the question. In a right angle triangle ABC, ABC is 90 degree. So this is 90 degree. We have drawn this properly. AB is equal to 5 centimeter. AB is 5, and then BC is 12. No problem. BC is lesser than AB, so don't go with the diagram. It's just for our understanding. The radius of the circumcircle of the triangle is very simple. If this is 5 and this is 12, this will be 13. Pythagorean triplets. Pythagorean triplets. Right angle triangle. Correct. So like we have already understood, AC is the diameter. If diameter is 13, then what is radius? 13 by 2, which is nothing but 6.5. 6.5 is option C. Clear? Hope this is clear. Let's go to the next one now. Okay, next question. Well, in a right angle triangle, the product of two sides is equal to half of the square of the third side. Fine. What they are saying, let me draw the triangle for our reference. Okay. I'll call this side as A, this is B, and this is, let me call it as H, hypotenuse, right? What they are saying is the product of two sides, A into B, let me draw it. Okay, I think this must be visible if you are using your smartphone. A into B is equal to H square divided by 2. They have clearly mentioned the other side is hypotenuse. The product of two sides is equal to half of the square of the third side, that is hypotenuse. So this is what they are saying. We know from Pythagoras theorem that A square plus B square is equal to H square. Yes. So let me equate these two equations for H square. So 2AB is equal to A square plus B square. Now you tell me, when can this equation be proper? When it can satisfy? Only when A is equal to B. When A is equal to B, left hand side becomes 2A square, right hand side also becomes 2A square. Hope this is clear. So if A is equal to B, then these two sides must be same, and it's a right angle triangle. Then the angles other than this 90 degree must be 45 degree each. Yes. Well, one of the acute angle must be 45 degree. Hope this is clear. Move on to the next one. Okay, question number 30th. Simple, straightforward question. A ship is sailing 12 kilometers towards south from a particular place, covered 5 kilometers towards, 5 kilometers more towards east. That means from south to east, it has changed the direction by how much? 90 degree. You can visualize it. You should not be using pen and paper to solve this question. Okay, one direction is 12, other direction it is 5 kilometers, and south and east, the direction, the angle between these two lines must be 90 degree. So it's a right angle triangle. And in the question, what they've asked is the straightway distance of the ship from that place will be the hypotenuse, which is nothing but 13, because 5, 12 and 13 are Pythagorean triplets. The answer is directly option D, 13 kilometers. All right, next one. Okay, in triangle ABC, let's say this is ABC. DE is perpendicular to AC. DE is perpendicular to AC. Achha. Where D is on AB. D is on AB and E is on CB. E is on CB. AB is 10. AB, this is 10. AD is 4. AD, this is 4. If AD is 4, what is BD? Obviously 6. BE is to CE. BE is to CE. Okay, fine. Now listen, this is very simple question actually. Can I say triangle BDE is similar to triangle BAC? B is same, and then this angle D angle must be equal to A because D is parallel, and this must be equal to obviously this, right? When that is the scenario, the sides will be proportional. With that, I can say that BD divided by AD must be equal to BE divided by AC. Clear? So what is BD by AD? BD by AD is 6 by 4 or 3 by 2. That must be equal to this BE by AC. BE by AC or C. That is 3 by 3 is to 2. Great, fantastic. Let's move on to the next one. Question number 32. Very similar to the previous question. Just go through it. In a triangle ABC, a straight line parallel to BC intersects AB and AC at DE. Let's say this is the parallel line. One second. If you further read, we can draw the diagram a little more accurately. AB is equal to 2 times AD. That means, if for example, let's say if this is D, then AB can be 2 times AD, right? Yes. All right. Okay. So this is D, then this is E. Great. So AB is equal to 2 times AD, then DE is to BC. Again, you know, ADE is similar to ABC because of the reasons that we have discussed in the previous question. I mean, if we have to just repeat that, see, A is anyways the common. Since DE is parallel to BC, then obviously D will be, this angle will be equal to this, and this will be equal to this. Clear? So now, AD divided by AB will be equal to DE divided by BC because of similarity. And that's what we need, that is DE is to BC, which will be equal to 1 by 2. AD divided by AB is nothing but 1 by 2 because they have clearly mentioned AB is equal to 2 times AD. Hope the answer is clear. Option is C, 1 is to 2. Next one. Okay, next question. This is also similar to the previous one, but there's a small twist. Okay, let's see how to solve this. In a triangle ABC, let's say this is a triangle ABC. Okay. All right. A, B, and C. E and D are points on sides AB and AC respectively, such that ABC is equal to AD. Fine. E is a point on AB, and let's say this is D. E and D. Fine. So let me join that. So what they are saying is this angle, that is angle B, must be equal to this. Okay, if that happens, all right, A is anyways common between two triangles, that is AED and ABC. Between these two triangles, angle A anyways it is common, then angle E must be equal to angle C. Hope that is clear. Okay, that means these two are similar. To establish similarity, if two angles are same, that is sufficient. The third angle will naturally be same. Great. So now observe this. They have given the edges, that is AE is equal to 3 and AD is equal to 2, then EB is equal to 2. EB is this is equal to 2. Great. So if they are similar, then observe, this is the very important point. AD divided by AB, all right, AB will be equal to AE divided by AC. Don't make the mistake here. AD by AD by AC is not equal to AE by AB. The reason is this particular angle is equal to the other one, that is B. If in case D was equal to C, then the other one, whatever the scope for making the mistake, that would be right. If D was equal to C, then AD by AC would be equal to AE by AB when E will be naturally equal to B then. So now the scenario is D is equal to B and C is equal to E, right? So in that case, what happens is AD divided by AB will be equal to AE divided by AC. Hope this is clear. Don't make the mistake in this case. I've seen many students make mistakes here in this particular point. The next part is, what do we need? We need DC. So DC is where? DC is inside AB, right? DC is in AB. If I get AB, I can remove that AD part, then I will be left out with DC. So that's the logic. Now what is AD? AD is given as 2. And what is AB? Where is AB? AB is 3 plus 2, that is 5, correct? Which will be equal to AE is again 3 divided by AC. So AC is equal to 5 3 is 15 by 2, 7.5. But what is AC? AC is nothing but AD plus DC. So AD is 2 and this is equal to 7.5. That gives me DC to be equal to 5.5 centimeters. Hope this is clear. Brilliant. Let's go to the next one. Now read this question. If the opposite sides of a quadrilateral and also its diagonals are equal, then each of the angles of the quadrilateral is. Okay, now see, you need not even answer this question. Your fundamentals, your basic has to be strong. Now they're saying that each of the angle of a quadrilateral is equal to. When is that possible? There are overall 4 angles in the quadrilateral. The sum of all the 4 angles must be equal to what? 360 degree. Then if each of them has to be same, then it is 360 divided by 4, 90 degree over. Whatever they have mentioned that opposite side of quadrilateral and also diagonals are equal, all that you need not even consider to solve this question. Hope this is clear. If they have given that each of the angles of the quadrilateral is, that means they are indirectly saying that all the angles are of equal measurement. So that is nothing but 360 divided by 4. Why 360? Because sum of the angles in a quadrilateral is equal to 360 degree. Answer is option A. Within 3 seconds, or let's say 5 seconds. Okay. Next one. All right. It's a question based on a square. All right. So inside a square ABCD, initially let me draw a square. Let's say draw a big square so that it's visible to you. 4 vertices. Perfect. All right. Okay, I hope all of you can see this. Yes. So inside a square ABCD, BEC is an equilateral triangle. Okay, BEC, equilateral triangle. Maybe like, let's say I can take till here. Yes, approximately. One second. Yes. And similarly, right. So this is BEC. Okay, approximately. E could be somewhere here, or it could be where we have written. No problem. BEC is an equilateral triangle, and then CE and BD. CE, that is this line, and BD, that is a diagonal, BD, they intersect at O. This is O. All right. Then what is angle BOC? What is this angle? This is the question mark. This is a question. Very simple question actually. What is this? C is 60 degree. Why? They have clearly mentioned ECB is an equilateral triangle. Okay, that's one thing. Now, what is this angle? This angle is 45 degree. How can you say that? Because BD is a diagonal, and BD the diagonal bisects the angle in square, right? So if that is the case, if this is 45 degree and this is 60 degree, what will be this? It's nothing but, naturally, if 15 has, you have taken 15 from 45, if you have to make this 60, okay, then you add 15 to 60, it becomes 75. Anyways, that is my logic. You can do however you want. 60 plus 45 plus this angle must be equal to 180 degree. That gives you this angle to be equal to 75 degree. Great. Done. BOC is equal to 75 degree. Don't worry about the way in which I have calculated. Every individual will have your own style of calculating. So what I do is, for example, this 60, if in case this was 60, okay, it is not 60 now. If in case this was 60, then even this should be 60. Now 45 is 15 less than 60, that means this must be 15 more than 60, that is 75. That's how I calculated. It's not necessary that even you should be doing in that way. All right, hope this is clear. Very simple question, nice question. Let's go to the next one now. 36th, it's a formula based question. You must be knowing how to represent the sum of the interior angles and what will be the sum of the exterior angles in a regular polygon. Okay, in a regular polygon, the sum of the interior angles is given by 2n minus 4 multiplied by 90 degree. Okay, and the sum of the exterior angles will be equal to 360 degree. Okay, this is a knowledge based question. You must be remembering this. Okay, so now what they're saying is 2n minus 4 into 90 must be equal to twice the sum of all the exterior angle, that is 2 into 360 degree. Great. So 90 360, you get 4 times, so this is 8, and you have 2n is equal to 8 plus 4 12, or n is equal to 6. Option D. Hope this is clear. Move on to the next one. 37th, among the angles 30, 36, 45 and 50 degree, one angle cannot be an exterior angle of a regular polygon. This is repeated, will be cancelled when this test will be uploaded for you guys. The angle is, okay, now observe, we have understood this, we have learned this in the previous question, that sum of the exterior angles must be equal to how much? 360 degree, right? So sum of the exterior angles must be equal to 360 degree. Then what is this sum of the exterior angles? Is nothing but, in a regular polygon, that is same. I mean, the exterior angle is same. So if I consider E as the exterior angle into the number of sides, this must be equal to 360 degree, right? So E must be equal to 360 degree divided by n, or n must be equal to 360 degree divided by E. So what is n? Number of sides. So 360 degree divided by E should give me a whole number, or a natural number. It cannot be a decimal. So that's our basis to find out what's the right answer for this. 360 degree divided by 30 gives me a natural number. So 30 can be an exterior angle. 360 by 36, obviously 360 is divisible by 36. Similarly 45. Now 45 into 2 is 90, 90 into 4 is 360, so 45 into 8 is 360. So 360 is a multiple of 45. What about 50? 50 does not divide 360 properly. So when you divide 360 by 50, you will get a decimal value. Hope this is clear. So 50 cannot be the exterior angle. Alright, it's a very simple, straightforward question. If you know this concept, it's a within 5 to 10 seconds question. Right? Next one. An interior angle of a regular polygon is 5 times its exterior angle. Sorry, then the number of sides of the polygon is. Now observe, very similar. The previous two questions and this one as well are dependent on your knowledge about the interior angle and the exterior angle in a regular polygon. Okay, I told you that the sum of the interior angles, in a regular polygon can be represented by 2n minus 4 multiplied by 90 degree. Okay, and the exterior angle, sum of the exterior angles is equal to 360 degree. Hope, this is something that we have already discussed. Now what they are saying is, an interior angle of the regular polygon is 5 times its exterior angle, and the interior angles of the regular polygon is same. If, for example, if there are 5 angles, okay, if there are 5 sides in a polygon, then all the 5 angles will be same in a regular polygon. Hope this is clear. So if the same case with the exterior angle. All right, now if this is the scenario, then if one of the interior angle is the exterior angle is 5 times the interior angle, if the exterior angle is 5 times the interior angle, I can clearly say that the sum of the interior angles must be equal to 5 times the sum of the exterior angles. Yes, everything is 5 times, so when you add them, the sum will also be 5 times. Simple, right? So 2n minus 4 into 90 must be equal to 5 times 360. 90 4 times 20 plus 4, so n is equal to 24 by 2 or 12 sides. That's it. Great. Next one. Next question, again based on the formula that we have been discussing, that is 2n minus 4 into 90, that is sum of the interior angles in a regular polygon, is equal to 1440 is what they have given, right? So 0 0 and 9 how many times? 9 1s are 9, 54 is 9 5s are 6s are. Okay, so 2n is equal to 16 plus 4, or n is equal to 20 by 2, 10. Option. So this has repeated many times. The concept of internal angles has repeated many times in SSC. So make sure that you know this particular formula, which is really important. That is 2n minus 4 into 90 degree is equal to the sum of all the interior angles in a regular polygon. Okay, next one. All right, question number 40th. Read the given to 2 and the interior angle ratio is given. Great. Then the number of sides of each polygon. Fine, fantastic. So we have seen that the sum of the interior angles is given by 2n minus 4 into 90, right? So if that is the case, what is an individual interior angle? Will be nothing but 2n minus 4 into 90 divided by n. Okay, this is the formula that we will be using to solve this question. So the first one amongst two regular polygons, the first angle can be represented by this formula 2 into n minus 4 into 90 divided by n, and the second one will be nothing but 2 into 2n minus 4 into 90 divided by 2n. Now why am I doing this? Because they have clearly mentioned that the ratio of these two is equal to 3 by 4. The ratio of these two, that is the interior angle ratio, is equal to 3 by 4. And in the same formula, I have also used another data, that is the ratio of number of sides, that is 1:2. If this is n, this has to be 2n. If this is n, this has to be 2n. Hope this is clear. Now aram se simplify it, don't make mistakes. N and n you can cancel, 90 and 90. So you have 4 times 2n minus 4, which will be nothing but 8n minus 4 for the 16 will be equal to 3 times 4n, that is 12n minus 4 3s are 12 divided by 2. So I can take this here and multiply this by 2. So 8 to the 16n minus 12n is 4n is equal to 2 into 16 is 32 minus 12 is 20, or n is equal to 5. If n is equal to 5, 2n is equal to 10. Basically these two are the number of sides of each polygon, that is 5 and 10, option D. Clear? Question number 41. In a parallelogram PQRS, okay, so let me draw a parallelogram. All right, and then 1 2 sides. So yeah, so what happens in a parallelogram? Obviously the opposite sides are parallel to each other, and that gives us this information that the opposite angles must be same. Now what they are saying, PQRS in this parallelogram, P is 4 times of angle Q. P, this angle, is 4 times the angle Q. We know that angle P plus angle Q is equal to 180 degree in a parallelogram, right? So, and why is this? Because the opposite sides, opposite angles are same, and the sum of all the interior angles is equal to 360 degree. Hope this is clear. So now they are saying that angle P is equal to 4 times that of Q. So overall 5 times angle Q is equal to 180 degree. Fine. Yes. So angle Q will be equal to 180 by 5. Okay, simple. So this will be equal to how much? 36 degree. So Q is 36 degree. What have they asked? Measure of R. So R will be equal to nothing but 180 minus 36 degree, which is equal to 180 minus 36 is 144, right? So angle is 144, option A. That's it. Next one. Okay, next one. ABCD is a cyclic trapezium. Okay, now let me first draw the circle. Circle with center through point. Fine, great. Okay, and AB is parallel to DC. AB is equal to diameter of the circle. Now AB is equal to diameter of the circle. 1 second, let me just remove the label. Sorry. All right. Okay, fine. So a circle, and now I have AB as the diameter of the circle. That's what they've given. So one of the sides of the cyclic trapezium is the diameter of the circle. All right. So let me draw that. This is AB. And then DC, another side, is a parallel line to AB, right? DC. Now let me call this as DC. So this is D, this is C. Let's join these 2 points. So there you have your cyclic trapezium ABCD, right? So in a cyclic quadrilateral, not necessarily trapezium, in any cyclic quadrilateral, what's the overall property? The property is the opposite angles is equal to 180 degree. That is the fundamental. Fine. Now next thing is angle CAB is 30 degree. CAB. So let me join that AC. So they're saying that CAB, this is 30 degree. Great. So angle ADC is question mark. What are we supposed to find out? ADC is question mark. This is what, let me call it as alpha. Great. Now ACB, that is, if this is AB is the diameter, then at any point the 2 lines joining this particular point, okay, on the circumference will subtend, will make a 90 degree. All right. If this is 90 degree, then what about this? If I get B with the property which I just mentioned, that the opposite angles, the sum of the opposite angles must be equal to what? 180 degree. I can get the value of D. That's the overall logic. So B is nothing but 180 minus 90 minus 30, which is equal to 60. So B is 60. So B plus D must be equal to 180. That gives alpha to be equal to 120 degree. Hope this is clear. Option B is the right answer. Great. Next one. All right. For the third question, I have already drawn the diagram related to this question. Okay, it's a cyclic quadrilateral. I have taken it as, randomly I have drawn something, that is ABCD, wherein AC and BD are diagonals. So always remember the theorem, and there's a big proof. You don't have to actually solve that. And what is it? This particular length, that is AP into this particular length. If this is the point of intersection of 2 diagonals, then AP into PC must be equal to DP into PB. Okay, so this is the point of intersection, and these 2 lengths, the product of these 2 lengths must be equal to the product of these 2 lengths. All right, now I will just demonstrate that once. Just observe. I take any point, let's say that and let me take this. All right, some random 4 points on a circle. So what I'm trying to say is, this is the center of the circle, so don't worry about that. That need not be the point of intersection. The diagonals okay, fine. All right, let me say this as P, that is the point that they are mentioning. Now this, if this is A and if this is B, and if this is C and if this is D, then in a cyclic quadrilateral, okay, always remember that A into B must always be equal to C into D. Okay, it's a basic property, it's a basic theorem. Basically, you would have actually done the proof of it in your high school. All right, you would have forgotten it. You don't have to actually do that when you're in the exam. It's something that is very fundamental and you are supposed to remember this. Okay. Question number 44. ABC is a cyclic quadrilateral. A, B, C, D. Okay. Side AB is extended to E in such a way that BE is equal to BC. If angle ADC is 70 degree, angle BAD is 95 degree. What is this angle? Angle DCE. Alright, so this angle is what we are supposed to find. Now, two things to remember. One, in any cyclic quadrilateral, what happens is the opposite angles, they sum up to 180 degree. That's the first thing. Second thing is, this is an isosceles triangle, CBE. Two sides are same. That means two angles will also be same. So, for example, for BC, the opposite angle is this one, that is E. For BE, it is this. So, these two angles will be of same measurement. Okay, these two things that we need to remember. Considering these two factors, we can easily solve this problem. It's a very easy question. Well, so 95 plus this angle must sum up to 180 degree because they are opposite in nature, opposite angles of a quadrilateral. So 95 plus 85 is equal to 180 degree. Correct? Fine. Similarly, if I find this, let's first of all identify what's the whole plan. The plan is to get this value and then get this value, sum that to get DC. Fine. So how do I get this now? I can get that if I get the value of B, that is this angle, because ABE is a straight line. So if I get to know the value for this angle, then I will also get to know the value for this one, because this will be 180 minus this. Fine. So if I get this value, that is CBE, if I get CBE, then easily I can get the value of BCE or BAC, because they both are same and the sum of these three angles must be equal to 180 degree. Fine. So let's get started now. 70 and this one, this is 110. All right. So 110, if that is 110, this will be how much? 70 degree. Clear? Okay. So if this is 70 plus 110 must be equal to 180 degree, right? So 110 must be equal to sum of this C and E. So that gives me 55 and 55 because they are same. Hope this is clear. So 85 plus 55 is your answer, which is equal to 140 degrees. Okay. Now I'll just summarize once. They have given ABCD and BE is B is extended to E, so that BE is equal to BC. Okay. Next, they have given ADC, that is 70 degree, and then BAD is 95 degree. So we will get to know the values of these two, which is nothing but 95 plus 85 is 180 degree, 70 plus 110 is 180 degree. Great. So this must also be, it's a straight line, so this must be equal to 180 minus this, so it is nothing but 70. These two are same because it's an isosceles triangle, so they both should sum up to 180 minus 70, right? So or 180 plus C plus E must be equal to angle C plus E, or to be more specific, CBE. Fine. BCE, that is C, and then E, obviously there is only one, there is no confusion. This is equal to, this must be equal to how much? Oh, sorry, one second. 70 plus BCE plus CEB must be equal to 180 degree, correct? So that gives me these two values to be equal to how much? Sum of this is 110. They both are same, so each of them will be 55, 55. So anyways, fine. So what we need is DCE, which is going to be the sum of 85 and 55, which is 140 degrees. Hope this is clear. All right. Okay. ABCD is a cyclic quadrilateral. ABCD in such a way that AD is the diameter. Fine. So it passes through the center. If DAC is equal to 55 degree, DAC, so you will get one triangle. This is 55 degree. Then the value of ABC. So this is the question mark. This is what we are supposed to find. Easy question. Look at this triangle ACD. The base of that is the diameter, right? On the chord or on the diameter, if you draw any triangle, okay, this angle, I mean the vertex which is on the circumference, it will always be, this angle will always be 90 degree. Okay, so if this is 90, then sum of the angles of the triangle, we all know it is 180 degree. So we'll get this value, and then D plus B must sum up to 180 degree. The reason being, cyclic quadrilateral, opposite angles must add up to 180 degree, correct? So this will be nothing but 180 minus angle D will be equal to 180 minus 90 plus 55. This is 145. So angle is 35 degree. That is 180 minus 45 is 35 degree. And again, 180 minus this 35 will be once again 145 degree, correct? The same calculation. So angle B is 145 degree. Option C. Clear? Okay. See, easy question. Nothing to worry. Next one. 3 consecutive angles of a cyclic quadrilateral are in the ratio 1:4:5. So I'll take this as x. So this will be 4x and this one 5x. Assume this as y. The measure of the fourth angle. So we need y. Sum of the opposite angles in a cyclic quadrilateral is equal to 180 degree. That gives me x plus 5x, 6x is equal to 180 degree, or x is equal to 30. If x is 30, 4x, this angle will be equal to 4 into 30, 120 degree. If this is 120 degree, then y will be equal to 180 minus 120, 60 degree. Reason being, opposite angles in the cyclic quadrilateral, the sum must be equal to 180 degree. Option B. Okay, question number 47. ABCD is a trapezium. This is a trapezium. AD is parallel to BC, and then diagonals AC and BD, they intersect each other at this point, and they have called this point as O. AO is given. AO is the point of intersection of the two diagonals. So AO is 3 and CO is x minus 3, and then so and so. Fine. Now observe. So what is a trapezium? This is a trapezium, all right. ABCD is a trapezium. This is also a trapezium. This is also a trapezium. This is also a trapezium. So what is this? Is also a trapezium. So what does that mean then? Any quadrilateral wherein the two sides are parallel to each other. Okay. If two sides of a quadrilateral, if they are parallel to each other, you get a trapezium. Fine. Now there is an interesting property in trapezium that you need to understand. What is that? I mean, the other properties for the quadrilateral, like the sum of all the angles will be equal to 360 degree. All that remains the same. Opposite angles need not be equal to 180 degree in this case. Okay, that happens only in cyclic quadrilateral. So don't get confused. But there is one more property in trapezium. What is that? Observe very carefully. I will not write something on the screen because since I'll be moving, it will not be in sync with the diagram. So, but just for understanding, we will assume that this particular point, wherever the diagonals intersect, is called as O. This is called as O. Okay, I'll just rub it now. I mean, okay, fine. So, AO divided by OC. Okay, this point to this point to from O to C. Okay, will be equal to OD divided by OB. Hope this is clear. This particular measurement OA, now I can write and later I can rub. Okay, So OA by OC is equal to OD by OB. Fine. Like I told you, I'll be rubbing this O now because I want to show you how it behaves, and whatever I write will not be in sync with the diagram. So that's all. Right. Now observe. We'll assume that this point of intersection of two diagonals as O. Fine. Just observe that I'll be moving this. Now what did I say? OA by OC is equal to OD by OA. Observe it here. If this length is less than this, then OA is also less than OD in such a way that this ratio remains the same, that is OA by OC is equal to OD by OB, right? So similarly, observe it even now. OA by OB, okay, should be equal to OD by, oh, it went on the other side. Now it's going to change. Now it is going to be OD by OC to be equal to OA by OB. I hope you are following. Since I moved the point to, after D, anyways, we'll do it in this side only. So probably you can observe it now. This is very simple. You know it. It's a rectangle. It will follow. Hope you are following. The ratio from this section, OA by OC is equal to OD by OB. That's what I want you to observe. That's all. So even now you can observe. This is O, so OA by OC must be equal to OD by OB. Yes? Okay, fine. So keep this in your mind. Fine. If you know this particular property of trapezium, there are so many problems that you can solve. That's the only reason I am trying to just simulate and play with this. Okay, so now for this question, now I'll fix it. I'll make it as O. What is OA? They have given AO is equal to 3, and this is CO is x minus 3. So let's substitute in this particular equation. That is 3 divided by x minus 3 is equal to OD is x minus 5 divided by OB is 3x minus 19. That gives me 9x minus 19 into 3 times 57 is equal to x minus 5 into x minus 3. So it's going to be x square minus 5x minus 3x is minus 8x, and then plus 15. So x square minus 8x minus 9x is minus 17x, plus 15 plus 57, okay, is going to be 62 plus 72 is equal to 0. So then 72 and minus 17, so 72 is 9 into 8, right? So minus 9x and minus 8x. And if you take things common, x and then 8, you will be left out with x minus 9 into x minus 8, or x is equal to 9 or 8. Yeah, answer is option D. This part, let me just solve it for you, no problems. X square, this is plus 72. If I take x common, you will get x minus 9, or I'll take minus 8 common. 1 second. Yes, okay. This is also x minus 9. So x minus 8 into x minus 9 is 0, or the value of x is 8, 9. Yeah, hope this is clear. So next time when you get a problem on trapezium, try to apply if in case there is a necessity for this particular property. Great. Let's go to the next one now. Okay, if PQRS is a rhombus, what is rhombus? All the sides must be of equal length, right? So PQRS. Great. Angle SPQ is 50, angle SPQ is 50, this is 50 degree. Then opposite angle must also be 50 because it's a rhombus. And Q and S, well, so P plus angle Q plus angle R plus angle S must be equal to how much? 360 degree. We know P and R is 50 and 50, that's 100. Q and S are same, opposite angles are same, so let me call it as Q only, 360 degree. So Q will be equal to 130. This is 130. And then we have angle RSQ, RS and Q. Basically, we're talking about this one. Well, in a rhombus, QS, the line joining uh, the opposite vertices or the diagonal, is definitely the angular bisector. So this particular angle will be half of that of S, which is 130 divided by 2. Why 130? Because Q is equal to S, and Q we have found it to be 130, right? Yes, so 130 by 2 is nothing but 65 degree. That's it. Option B is your right answer. Great. Next one. ABCD is a cyclic trapezium in which AD is parallel to BC. Okay, so AD and BC, they are parallel. If angle A is equal to, sorry, if angle ABC is equal to 70 degree, that means this is 70 degree, then angle BCD, so we need this one. Two things to remember to solve this question. One is two things to consider. That is, the first thing is it's a cyclic quadrilateral. Second thing is trapezium, that is AD is parallel to BC. Now, why they are important, I'll just show you. Okay, anyways, so I'll use the marker itself. For example, let's say if I extend this line, okay, all right, consider that AB, it's one big straight line, and then BC and AD, they are parallel to each other. They are parallel lines. So this one, the AB line, what I'm saying, it is transversing. That means it is cutting these two parallel lines, right? So then it's very simple to observe that this angle must be equal to this. Hope this is clear. Yeah. So if that is equal, if this is also 70 degree, then what is this angle? Straight line, so 180 minus 70, which is nothing but 110. Hope this is clear. Next thing is, since it is cyclic quadrilateral, our first point, opposite angles must be equal to 180 degree. So 180 minus 110 should be equal to angle C. So that is nothing but once again 70 degree. That's it. So M and N are the midpoints of the diagonals. Let's say this is M, midpoint of AC, and this is N. All right. Then the length MN. All right. Okay. Very nice question actually, though it is just knowledge based. I mean, you can prove it, not necessarily now. So this is MN. MN is equal to half of the difference, that is 8 minus 4, difference of the parallel sides. Okay, so remember this. Another thing is, if in case you join the midpoints of the legs of the other sides, I mean the non-parallel sides, okay, let's say AB and then let's say this one. Okay, if you join these 2 points, let me call it as XY. If you join these 2 points, they will also be parallel to both AD and BC, and XY will be equal to half of 8 plus 4. Just remember this. Fine. They're all properties. Okay, you can, I mean, if you're really interested and if this is interesting you, please go through some books on geometry. It could be any of the books, or I mean, it can also be Google, YouTube. There are so many videos. Learn these properties. Okay, if you know the properties of all these quadrilaterals, or be it in mensuration, that is cone, cylinder, if you know the properties, now you can solve the problems very quickly, very easily. Okay, fine. Next one. The length of common chord of 2 intersecting circles. So let me make them intersect. One second. Yeah. All right. Now you have 2 circles which are intersecting. Okay. They're saying that the length of the common chord of 2 intersecting circles. So common chord for these 2 can be only this. Let me call it as AB. If the diameter of circles are 30 centimeters, diameter is this one, diameter is 30 centimeters, and 26 centimeters. So I'll take this as 30 and this is 26. I mean, don't go with the scale. Then the distance between the center is distance between the center. For example, if this is, let's say, O1 and this is O2, what we need is this distance. So what is that you're supposed to remember or understand before you actually solve this question? That is nothing but the line joining the centers. It bisects the common chord. Okay. Now, what we'll do is we'll take the diameter in this way. All right. Hope this is clear. Then they have clearly mentioned that one of the diameters is 26 centimeters. So radius of this becomes 13. Radius of the other circle, I can take it as 15 centimeters. And then I told you very clearly this line, the line joining the center, it bisects the common chord, right? So what will be this much? For example, let's say if I call this as C. So what is AC? AC will be equal to, this is 24, common chord length is 24. So AC is going to be 12. That's it. Now you have, this is right angled. Okay. You have 12, 13, and there is one more number which forms a Pythagorean triplet, that is 5, 12 and 13. So I can directly write O1C as 5. Now what about CO2? CO2 15, 12. 15, 12, what's the ratio, common ratio? 3 and 5, correct? 4 3s are 4, not 3 and 5, it is going to be 3 4s are 3 5s are, right? So 3, 4, 5, again Pythagorean triplet, but the ratio is multiplying this number by 3. So 4 3s you get 12. So similarly 3 into 3 you get 9. So this is 9. CO2 is 9. So overall O1, O2 is nothing but 5 plus 9, which is nothing but 14 centimeters. Yeah, hope this is clear. Great. Let's move on to the next one. Okay. AB and CD are two parallel chords of a circle such that AB is 10 centimeters and CD is 24 centimeters. If the chords are on the opposite sides of the center, perfect. The distance between them is 17 centimeters. So let me draw a line passing through the circle, a perpendicular line passing through the circle, joining both the chords. So that will be 17 centimeter. Then the radius of the circle is radius. Okay. Radius can be expressed, I mean, I'll express it in two ways. One is this is R and also this is also R. Great. Well, now everything is given. The distance between the chords is given as 17 and then the lengths of the chords. So if this is 10, if AB is 10, let me mark one more point as, let's say, C, then BC will be equal to 5. Similarly, not C, I'll make it as E. Already have C. So similarly, I'll make this F. FD will be equal to 12. Okay. Then O the center, I'll call OF as X. So EO will be equal to 17 minus X. Correct? FE is equal to 17. So I'll assume OF as X. So EO will be equal to 17 minus X. Great. Next thing is very simple. OD must be equal to OB. Okay, and you have 90 degree here. The reason being, the line joining both the chords, it is perpendicular to the chord, to both the chords. So this is also 90 degree and also angle E. I mean, this particular angle is also 90 degree. Great. That gives me 17 minus X whole square. 17 minus X whole square plus 5 square must be equal to x square plus 12 square. So what are we doing here? Since we know that, radius, these two lines, they represent radius, I'm trying to equate for that. This particular triangle, in this triangle, that is EOB, EB square plus EO square is equal to R square. In the triangle ODF, OF square plus FD square is equal to R square. So when you equate that, the same thing, you will get the same thing in terms of X. solve this, you will have 17 square 289 plus x square minus 34x plus 25 is equal to x square plus 144. X square gets cancelled, and 34x, you take it to that side, so it will be equal to 289 minus 144 is going to be how much? 289 minus 144, 189, 149, 145. 145 plus 25 is going to be 145, 150, 170. Okay, so x will be equal to 35 into 5 is 170, so x is 5. You got the value of x as 5. Now we can go with Pythagorean triplets 5, 12 and 13. Okay, so r has to be equal to 30. All right, not a difficult question, just that when you are solving it, do it fastly, do it quickly. That's it. Let's go to the next one. The length of the common chord of two circles. This is the common chord. Let me call it as, let's say, CD. Of two circles of radii 30 centimeters. So I will join this. This is 30 and this is 40. So why am I joining specifically DB? You will get to know. Whose centers are 50 centimeters apart. So AB is 50 centimeters. Okay. Now, what do we need? We need the length, that is DC. Now, one thing you need to understand, when the centers of two circles are joined by a line, let's say AB here, it bisects the common chord. Okay, it leaves you with two line segments of equal length. Okay, so that is the basis with which we can solve this problem. All right, equate these two, and before that, let's assume, let's say this is E, AE as x. If AE is x, EB will be equal to 50 minus x. All right, so CE is equal to ED. CE is equal to ED. Now, what is CE? CE is, using Pythagorean theorem, since this is 90 degree because it bisects, 30 square minus x square is CE, right? 30 square minus x square. What is ED? ED is 40 square minus 50 minus x whole square. I mean, basically, you can just square it since you are equating, no problem, right? So 40 square minus 50 minus x square. Solve this, that's all. It's pretty simple. So 900 minus x square is equal to 1600 minus 2500. Again, it will be minus and then plus 100x. Yeah, minus x square cancels. This is minus 900, so 900. So 100x will be equal to 1800, or x value is 18. So what is x? X is this. This is 18. If this is 18, what will be this value? 18 is to 30. It is 3 is to 4 or 3 is to 5, 6 times. Okay, 3 is to 5. So this is equivalent to 3. This is equivalent to 5. Then this must be equivalent to 4. Pythagorean triplets, right? If it is equivalent to 4, multiplication factor is 6. So 4 into 6 is 24. This value, this side is 24. We can do all this mentally. I'm just demonstrating this to you. Right? So C is 24. If C is 24, ED will also be 24. So CD, the length of the common chord, will be equal to 24 into 2, 48. Simple question actually. Great. Let's move on to the next one. Next one, 54th, very easy question. Two circles of same radius, 5 centimeter, intersect each other at A and B. If AB is 8 centimeters, this AB is 8 centimeter. Let me join the centers. We know that the line joining the center of the circles, it bisects the common chord. Common chord here is AB. What else they have given? The radius, right? So we are supposed to find the distance between the centers. Fine. Very easy question. We'll see how we can solve this. This is nothing but 5. This is also 5. They have given AB is equal to 8. and we know that this is the midpoint because it bisects, right? So let's say this is E. Then this value will be 4. 1 second. Yes, this is 4. If this is 4, think about the Pythagorean triplets that we have used in the previous problem. So 3, 4, 5. Similarly, this is 3, 4, 5. So distance is 3 plus 3, 6. That's all. 6 centimeters. Hope this is clear. This is a right angle triangle. You know the radius is 5 and you know the common chord length is 8 by 2. The reason being the common the line joining the centers, it bisects the common chord. So AE will be equal to 4. Similarly, EB will also be equal to 4. Fine, but we don't need EB now. A is 4 and AO1 is 5. So EO1 will be equal to 3. The reason being it's a right angle triangle. Similarly, OE will also be equal to 3. Distance between the centers is 3 plus 3, 6. That's all. This must be solved within around 10 seconds or 15 seconds. The moment you see the question, imagine this, or let's say around 20 seconds. Fine. All right. So I've just taken, I've opened this website gradestack.com, direct common tangent, just to give you an idea about what is that common tangent. CD, you can just see. Okay. CD is the direct common tangent, or AB is the direct common tangent for two circles. So I've studied all this in your high school. Anyways, just a revision. So the length of the direct common tangent is given by, it's a direct formula based question. Distance between the two circles, d square minus r1 minus r2 whole square, right? So that will be equal to the square of the length of the direct common tangent. Fine. So we'll implement the same thing here. So it's going to be distance between them is given as 13 centimeters. So 13 square minus 7 minus 2. 7 minus 2 is 5 square. So 13, 5, Pythagorean triplet has to be 12 square, right? Or you can even calculate. So 169 minus 25 is 144, which is nothing but 12 square. So if you are getting this as 12, basically CD square will be equal to 12, and CD is equal to how much? CD square is equal to 12 square, sorry, CD is equal to 12. So answer is option A. Similarly, just you can have a look at this. This is gradestack.com. So you can, it's nice, good website. You can get your, if you have any doubts in geometry, please, you can go to this particular website. Transverse common tangent is PQ and RS. So to find the value of that, you just have to subtract. D square minus, then you have to add the radius, R1 plus R2. So here we had subtracted. Fine. All right. Okay. Let's move on to the next one. 56th. Let P and Q be 2 points on a circle with center O. Let's say this is O, this is P and Q. If two tangents of the circle through P and Q meet at A with angle A, that is PAQ, as 48 degrees, then angle APQ, so we'll have to join these two lines. Fine. Okay. What we want is this. Simple question, in fact. Observe any two tangents which are joined from the same point, same exterior point. Fine. So the length will be same. So if they are same, then it's an isosceles triangle. The opposite angles will also be same. So angle P is equal to angle Q. And then we know sum of the angles in a triangle is equal to 180 degree. So angle P plus Q, or I will write it as 2 times angle P plus 48 degree is equal to 180 degree. So 180 minus 48 is 132. Fine. P is equal to 132 divided by 2 will be equal to how much? 65, 66, right? 65 into 2 is 130, 66, right? Option C. Simple? Yes. Question number 57. AB is a diameter of a circle. Let's say this is AB, and let's mark this as the center. C is a point on the tangent. So tangent, if I draw a tangent here, okay, it will be exactly perpendicular to the radius. If I draw it, okay, that has to be taken care of. Fine. So this is 90 degree. All right. I'm sure you will be knowing this. If you draw a tangent and you join that point, or if you draw a radius from there, you will have it will be 90 degree, the angle between the radius and the tangent, right? So if AB is equal to 8 centimeter, AB is 8 centimeter, okay. All right, this is 8 centimeters, and then AC is 6, where C is a point on a tangent drawn at A, right? Let me take this as C. So this is how much? 6. Now what is BC? Clearly it's a right angle triangle, very simple. So this is 8 and this is 6. This has to be 10. Why? 3, 4 and 5 Pythagorean triplets, and it's the same ratio. 6, 8 and 10 is nothing but 3:4:5, right? So answer is 10. That's all. Next one. Okay, 58th. The radius of a circumcircle of a right angle triangle. Now the moment they say circumcircle of a right angle triangle, means one of the sides has to be the diameter. The reason being, only then this angle will be 90 degree. Hope this is clear. So if radius is 15, then the diameter is going to be how much? 30. So we have got the hypotenuse of the right angle, so 30. Look at the options. This is not, you don't have it. And hypotenuse is 30. That means the longest side is hypotenuse. So even this is eliminated. It cannot be less than the remaining two sides. I have these two. Right angle triangle. Look at the ratio. This is 3:4:5. 6 3s are 6 4s are 6 5s are. It's Pythagorean triplet. So this is the triangle that we're talking about. But anyways, let's also look at the other option. 30, 24 and 25 does not form a right angle. Okay, 24 square plus 25 square is way high compared to 30 square. Hope that is clear. This is 625. This is 500 something. 30 square is 900. So 576 plus 625 is bigger than 900, right? So it cannot form a right angle triangle. The answer is option B. You need not even go for the rest of the data in the question. Great. Next one. Answer is option B. I hope this is clear. With this information that, right angle triangle, if it has to be right angle triangle inside a circle, all right, then the hypotenuse has to be the diameter. Okay, so that is the common sense. That's the fundamental. Fine then. Next question. 59th. O is the center of triangle AB, circumcenter of triangle ABC. Fine. So let's draw a triangle. Let's say this is a triangle. Let's say that this is the center, circumcenter O, and let's call this as A, B and C. Angle A is given as 85 degrees. This is 85 degrees. Then BCA, this is 55 degree. What is angle OAC? OAC, let me join this. This is what we're supposed to find, right? OAC. Okay, this is also a very easy question, very fundamental question. First thing is, in a triangle, the sum of all the angles must be equal to 180 degree. So 85 plus 55, you will get how much? 90 plus 50, 140. So 140 means B will be equal to 40 degrees. Hope this is clear. If this is 40 degree, then the angle formed at the center, okay, from the same 2 points, all right, will be equal to 2 times that of 40 degree, this angle, which is 80 degree. Fundamental. All this you must have studied in the high school itself. I mean, anyways, so if this is 80 degree, then once again look at this triangle AOC. AOC in this triangle, again the sum has to be equal to 180. That is one. Second thing is, AO and OC, they are radii. Length, is same. So it's an isosceles triangle. That means the opposite angles, that is this and this one, Okay, both the angles must be same. So that gives us a very, I mean, it makes the whole thing very simple, that the remaining part 180 plus 80 plus 2 times the angle OAC must be equal to 180. So that gives me OAC as 50 degree. Hope this is clear. This is 50 degree. Okay, option B. That's it. So let's move on to the last question of geometry. Okay, question number 60th. Nice question. So let's solve. Angle between the exterior bisector of two angles. First of all, what is this exterior bisector? Let's understand that. Let's say this is the triangle ABC. One second. A, B, C. Let's say I extend these two lines. This is the exterior angle of A and this is the exterior angle of C, right? Now, they're talking about the bisector of those exterior angles. So they meet somewhere here. Let me call it as M. Hope this is clear. Now, what else are they given? The angle between the external bisector of two angles. So this angle M is 60 degree, is what they are mentioned. Then the third angle. Okay, fine. Now listen. Our whole game plan is. Now before that, what is that we want? We want the third angle of a triangle. So we want this one. Fine. Our whole game plan will be nothing but get the value of this one. Let me call it as X and this as Y. Okay. This angle and this angle. Get the value of X and Y in the form of A and B, and then equate this AMC to 180 degree to get the value of those two, and then equate those to ABC, that is sum of this angle must be equal to 180 degree, and get the value of B. So let's see how we can proceed with it. Now X is equal to half of this angle. Hope that is clear. Let me call it as, let's say, I mean, it will become complicated, so just for your understanding, X is nothing but half of that, right? Because it is the bisector. So keep that in your mind. I will write X as 180 minus, this is angle A, divided by 2. Is this clear? Similarly, Y is 180 minus C divided by 2. Next, X plus Y plus 60 is 180 degree. So 90 plus 90, that is 180 by 2, 180 by 2, 90 plus 90, minus A by 2 minus C by 2. This is X plus Y plus 60 is 180 degree, or this is 120 degree, or A plus C by 2 must be equal to how much? 120 or 180 minus 120 is 60, or A plus C is 120. Hope this is clear. If A plus C, if A and C, if this is 120 degree, understand, if A plus C is 120 degree, then what is B? B must also be equal to, B must be equal to 60 degree, because A plus B plus C is equal to 180 degree. Hope this is clear. So if A plus C is 120 degree, I can directly say angle B is 60 degree. That's our answer, option C. Great. So what we have done here, very simple. This particular angle, that is X, is nothing but 180. 180 is nothing but this whole thing of straight line minus this angle A. If you remove angle A from 180, you will get this entire angle, the exterior angle. But X is nothing but half of that, because this line is the angular bisector, right? So X is equal to 180 minus A by 2. Similarly, Y is equal to 180 minus C by 2. The sum of these two, that is X and Y, plus 60 degree, that is this angle, must be equal to 180. Solving that, you will get A plus C is equal to 120. If a plus c is 120, b must be equal to 60 because a plus b plus c must also be equal to 180 degree. Hope this is clear. That's it. That's about geometry. Thank you so much.